Let's use these trig formulas in an integral. So I'm going to integrate sine cubed of x dx. This is an integral with a product of a bunch of different sine functions, but I'm not going to be able to use a u substitution. Derivative of sine is the cosine, and I don't see any cosines in this function. I'm not going to be able to use an integration by parts either. Maybe I could do something clever with that. But for any integral that's involving powers of trig functions, and just powers of trig functions, I want to use my identities. So, what do I have? I can replace a sine squared with maybe a cosine squared, or I can replace a sine squared with a cosine of 2x. My most popular identity is sine squared of x plus cosine squared of x equals 1. And this tells me that sine squared of x equals 1 minus cosine squared of x. Let's see what happens when I rewrite my integral using this identity. I have the integral of sine squared of x times another sine of x dx. So I'm just splitting that exponent. I'm going to use my identity here. So this integral becomes integral of the quantity 1 minus sine squared of x, which is then squared. Excuse me, that should be the cosine function. Times sine of x dx. Does that help? Well, I think so. Because I can find this derivative over here. What am I saying? The derivative of the cosine function is minus the sine function. The cosine function happens to be the most nested part of this formula. So now I can attempt a u substitution. I will say u equals the cosine of x, du equals minus the sine of x dx. I don't have exactly a minus sine of x dx, so I can rewrite my equation here to say that sine of x dx is worth a negative du. Let's rewrite this integral in terms of my u variable. So I have the integral of the quantity 1 minus u squared times negative du. And yes, you probably noticed about a minute ago that this exponent was wrong. But that's looking good now. My sine squared is equal to 1 minus cosine squared. And such. Here it is after my u substitution. I'm going to bring this negative out to the front of the integral. So I'm now working on the integral of 1 minus u squared du. I know that my antiderivative is going to be u minus u to the power 3 divided by 3, plus a constant of integration. Let me distribute my minus sign through there. I get negative u plus u cubed on 3 plus c. And the very last thing I do is I put my cosines back in. So this integral is equal to minus cosine of x plus cosine cubed of x divided by 3 plus the constant of integration.